Hello everyone, I'm representing batch 31 of our final year project and this is our model. The title of our model or the project is Multinozzle Manually Operated Sprayer. First and foremost, we'll come to the point that why we have designed this model or why we have taken out this project. So we know that the operator or the agricultural farmer, he has to carry the entire load of this tank. Like in full capacity, it will be around 20 kg, and he has to carry the whole weight on his shoulder. And he'll be given only one nozzle will be connected to this tank, so the spraying rate will be pretty less, and he has to again manually operate using his hand, and it will be a cumbersome and a major time consuming task for him. So now we'll look at the parts of our model. First and foremost, the tank, which is like it is available in the market directly, and we have taken the same tank and set up in the cart wheel here. So the other parts are the mainly the wheel, that is the diameter of the wheel is 18 inches, and we have two sprockets and a chain connected over it. We have the driver gear here, which is connected to the second sprocket, and the number of teeth here is 52, and this is directly meshed with the driven gear, and it has 32 number of teeth, and the shaft carrying the driven gear is its end is welded with the lever, and it's connected to the pumping rod section. We have a piston cylinder arrangement here, wherein the rotary motion can be converted into a reciprocating motion, pressurizing the fluid. We have nozzles used here, and the material we have used here is brass. So we have used 4 nozzles here. We can use any number of nozzles depending upon our requirement, and stability of this rod can be varied, and it can be inclined to any angle. If we want to spray it in any angular motion, we can incline it, and we can also vary the height of this rod, up and down motion we can use it. We have a tiny but a major part down here. It is the splitter. The splitter is used to invariably control the fluid motion or the direction of the fluid motion, and it splits the fluid to all the nozzles in equal pressure. So we have kept a handle here. The important or the major use of this handle is that if we don't require the continuous spray, we can use this handle to cut off the continuous spray and spray wherever it is required. And also we have used a cut-off valve to release the pressure whenever the mechanism gets seized. We will come to the supports of the nozzle head. So we have 2 plates here, right down here, and these plates are helpful for different types of sprayment. That is, this plate is used for the mist sprayment, and this is used for long sprays. So if we want only long sprays, we can keep it just like here, and this goes back out here, and we can use it for spraying. So if we want mist sprayment, we will keep this in like this in the forward direction, accompanied by this plate, and this is how it works. We'll come to the working mechanism of the model. So first we will fill the fertilizers down here in the knob. There is a filter to separate the unwanted or the foreign particles from the fertilizers. We have a knob down here, down there. There is that white part. It is used to suck the fluid in. It has to be always downward facing, not upwards. After filling in the fertilizers, we have to close this knob very tightly so that the pressure won't escape anywhere. For continuous spray in the nozzle, we have to keep this cut-off valve open, and the handle here may not be used because we are using this mechanism for continuous spraying here. When we pull the cart wheel, then this wheel will rotate, and it will directly rotate the driver gear. So when the driver gear rotates, the driven gear is driven, which is directly connected to the lever. So the rotary motion here that occurs in the driven gear will be converted into the reciprocating motion with the help of this lever, and as this lever is connected to the pumping rod down here, so the pumping action will take place. So in order to pressurize the fluid, the piston and the cylinder arrangement is useful here. So the whatever the pressure is here, it will be more, it will be converted to even more amount using the piston cylinder arrangement, that is using the reciprocating of the piston. As we pull the cart, we can see that the wheel is rotating, directly driving the driver gear and indirectly driving the driven gear. So the lever here reciprocates, causing the piston to reciprocate and pressurize the fluid. The pressurized fluid will be collected into the accumulator, which will be going through this pipeline, and through here it is going into the splitter. So the function of the splitter, it is to split the fluid in all the four directions, so it can reach the four nozzles out here. So the spray will take place in all the four nozzles in constant pressure. And for varying the height, if the crops are in greater height, so we can vary with the height as well. So if we want the spray in some angular portion, so we can rotate this till maybe 180 degree or so. After varying the height or the angle, we have a screw here, and a simple tightment can make it stabilize. We'll now show how the actual spray occurs. We will fill in some water instead of the pesticides spray. So here we go. That goes. So here goes the filter. So we'll close it tightly. And so now the actual film begins. So here let me set this cutoff wall or the knob open, and let me just pull this. So it will take some time to build up the pressure, and once the pressure is developed, the spray will occur. So this is the mechanism that is occurring out that I have said earlier. We have designed our model in such a way that the spray occurs in only one direction. That is, if we pull our mechanism in this direction, that is in the backward direction, so in forward direction the spray will not take place, because we have considered the safety criteria of the operator. That is, if we push the cart forward and if the spray occurs from the nozzle, the fumes will be hitting directly on his face. A lot of people won't be wearing any mask or any safety equipment. So we have designed our model in such a way that only the backward motion causes the spray to occur. The conclusion of our project is that there is a drastic reduction in the spraying time, and as well as the area covered will be more, because we are using multiple number of nozzles, and as I said earlier, the health hazard will go down as well. Thank you.